In today's class, I am going to start a concept called indexes. So, what is an index? Before going to index, let's see one. Let's go with this example, simple scenario. In a dictionary, you will be having a dictionary, right? What dictionary does? In dictionary, if you want to see a meaning for any word, then you can search. You can go to open your dictionary and you can search the dictionary accordingly. Okay. So now here in the dictionary, let's say if you are searching for a old some meaning for a word school, so what it does, first you'll go and see the letter S, then you'll go and see the second letter C, then you'll go and see the school. So it will be easy for you to search, right? Because the data is in a sorted order. Let's say in a dictionary, if all the letters are not in a order by way, and if you want to search certain word, certain letter or certain meaning for a word, okay, how you are going to do it will be hard for you to go and search because the data is not in a certain in a sorted order. So it will be difficult for you to search. It takes more time for you to even take some hours, some days to search a particular word, particular meaning for a particular word. Okay, but if the data is sorted, then what happens? It will be easy for you to see, to search and to search whatever the data you want. Okay, now in the same scenario, let's say there is a table here. In a table, let's go with the less records. You are having 1 2 3 4 5 6 records you are having. I think someone is not using headphones. I'm getting echo sound. Yeah, now I'm okay. So in the indexes, let's say there is a table which has a ID 6. We are having 6 IDs, or else I'll go in a simple the other definition, that will be cool. So I'll not give in a I'll give in a sorted order. So let's say we got 3 letters: 1 2 4 5 3. This is the data that I am having. If I want to, and there is one more called, there is 2 more records, and there is one more called 2 and 1. Okay, if I want to search 3, what my table does, what my system is going to do, if I want to search number 3 in my table, then what it is going to do, it is going to see record by record. So how many records do you have? 1 2 3 4 5 6 7. So we got 7 records. So what it is going to do, it is going to search all the 7 records, and so it will be doing a search for 7 records. And if that, let's assume that if the data is sorted, okay, when the data is sorted, what is going to happen? We'll have 1 1 2 2 3 4 and 5. This is after data is sorted. And if you want to search for 3, what it is going to do, directly it will go for the, see, it will not go this way, it will go for the 3. Okay, we got the 3 and it will get how it will go for the 3, that all we are going to see internally when the data is sorted, how the data is stored in the inside the table, that all we are going to see. Okay, when it is sorted, okay, here we got the 3 and automatically directly it will return the number. The same way in the dictionary, you will not, if you want to search something word which starts with S, okay, you will open certain page. Let's say you got the page called T, then you will have you will see, okay, S is before T, then you will go again, you open some less pages, you'll go again back 1 or 2 pages, so that you will guess letter S, then you will see whatever word you want in that which starts with the letter S, right? Same way the SQL server, it will not directly go to the 3. There it follows some steps. By using the steps, it will go to the number 3. Then automatically once it is found, then it will get the number 3. But here since you are doing 7 searches, right? Here you might do only 2 searches when it is for less data. If you are having some millions of records, 100 million records, then if you do record by record, you need to do 100 times, 100 million times. But if you create an index, then you might find your result only like 10 to 15 steps. In 10 to 15 steps, you will be finding your record in a table. If it is not sorted, if you want to find a record in 100 million records, then you need to search in all the 100 million records. So now what I am going to see is that I am going to explain you how the data is stored in the database. Okay, and when you create an index, what exactly is going to happen. Now there are two types of indexes I am going to cover later on. Okay, so let's say we got the data this way, 1 2 3 4 5 6 7 8, we got 8 digits, and this is not in a sorted by way. So not in the sorted by means the result is this way, 1 2 3 6 2 8 7, 1 2 3 4 5 6 7 8. Yeah, this is a data that is not sorted. Okay, let's say if you create index, then how the data is going to be sorted. In SQL Server always uses a method called binary tree. So most of you, I don't know you heard it not, binary tree is a method how the data is stored. It's a concept where it like we got some concepts, right? Binary tree is method, it's a method. This our index uses the binary tree method, so that if you want to find certain record in a table, it will be easy for you to find the record. So now the same data, if I create index is nothing but it will sort the data. If you create an index, automatically the data will be sorted on a table. That's it. The definition of the index means the data will be sorted. That's the only thing you need to remember. Now this is the data I have. So if I want to create index, what the system is going to do? First it will sort the data. Okay, and after that, so how many records I got? 8 records. So 8 means I'll taking 8 plus 1 by 2. So sorry, it is a even number, right? Even number means 8 by 2. If it is a odd number, then I'll be having, let's say I got 7 numbers, so I'll taking 7 plus 1 by 2. So 8 by 2 means 4th record. So it will take the 4th record, and 4th record will be at the center, and whichever the data less than 4 will be on the left side, greater than 4 will be on the right side. So less than 4 are 1 comma 2 comma 3, and greater than 4 are 5 comma 6 comma 7 comma 8. Out of this 1 2 3, so the 3 records, right? So 3 is an odd number, so 3 plus 1 by 2 is 2. So 2 is at the center. So 2 will be at the center, less than 2 will be at the left side, and greater than 2 will be at the right side. So 1 3. Same with the 5 6 7 8. So it is a 4. So 4 is a even number, so 4 by 2. You automatically will be getting as 2. So second record is 6. 6 will be at the center. Next 5 will be at the right side, and you got 7 comma 8. So out of 7 comma 8, it is 2 by 1. So first 7 will be at the center, 8 is a less, right? So 8 will be at the right side. Okay, this is the way how the data is stored. Now if I want to find any record here, so let's say the data is not sorted, and if I want to find a record called 6, the system is going to search all the 8 records. So it will be doing 8 scans on the table. Okay, now if after sorting the data, this is the way the data will be sorted inside the database. Okay, when you create an index, the data will be sorted in this way. Now if I want to search 8, so first it will go to the center record. It will see, okay, 4, it is at the top. You might call the top record is at the root level, the bottom record is at the leaf level. 1 3 5 7 8, they all are at the leaf level. So first it starts with the 4. Since you want to search number something, if you want to search number 8, then what it does, it will go to the top record. So 8 is greater than 4, it will go to the right side and come here. So 8 is greater than 6, right? It will go to the right side, come here. 8 is greater than 7, so it will come here. So how many searches you are doing? 1 search, 2 search, 3 search. So in the 4th search you found the record, because you are having less number of records, so that's why it is showing 4 searches. If you are having some millions of records, then searches will be very much reduced. Okay, so now you can see here how easy it is, right? If you want to search 8, now it is taking only 4 in the 4th. When you are in the 4th time, you are finding your record 8, but when the data is not sorted, you need to search 8 times. So where is 4 times, where is 8 times? Because you are having less number of records, this is a way. But if you are having some millions of records, in order to search a one record in the millions of the record where the data is not sorted, it might take you some so it will be you will be searching all the millions of records, that's the thing. But if the data is sorted, you might find your record in 10th or 15th place, 15th search, that's it, not more than that. Or sometime if the data is used, you might find the record within 100 search, but compared to million search, 100 search is a great, right, very effective. So in the this method you will be calling it as a binary tree. When you sort the data, the middle so nothing to worry about this formulas, you can leave. Only the middle record will be at the center, less than to that record will be at the left side, greater than record will be at the right side. The same, everything will be sorted here. Now if you want, we can go with the other example also. This is the main thing you need to understand. Let's say I got records 1 2 4 6 3 9 10 7 8 14 18 15. Okay, this is the data I am having. So this is not in a sorted by way. If I want to search something 8, then system will go and search each and every record. Even though I found here 8, right, but it will not, it will search other records also. So now how many times I am searching? 1 2 3 4 5 6 8 9 10 11 12 13. I am searching 13 times for getting my required data. Now if I create an index on this, then what happens? The data will be sorted 1 2 3 4 5 6 7 8 9 10 14 15 18. So this is the way. So here first it will take 1 2 3 4 5 6 7 8 9 10 11 12 13 13 records. 13 plus 1 by 2 is 7, 7th. So 7th record is this one. 7 will be at the center. Okay, less than 7. Which are the records we are having less than 7? 1 2 3 4 5 6. In this 3, 4 will be at the center and 1 2 will be at the right. So in that 1 will be at the center and 2 will be at the right side. Okay, I am keeping here in this so that you can see the numbers clearly. 4 7. Next for 1 it will be at the right side, and again we got one more in the 4 5 6. So in the 5 6 5 will be at the center, 6 will be at the right side. So we got,
excuse me, boss.
yeah,
in this example, suppose if we don't have the number 7, what will it take?
it will take the, let's say if we don't have 7, we don't have anything here. So how many records we are having? 1 2 3 4 5 6 7 8 9 10 11 12. Yeah, instead of 7,
We still have 15 numbers. Instead of 7, we have say 11.
okay,
Number is it going to take?
we got 11 here, we don't have any 7. So let's see 1 2 3 4 5 6 7 8 9 10 11 12 13. 13 numbers, right? 13 numbers means odd. So 13 plus 1 by 2, it is 7th number. 7th number 1 2 3 4 5 6 7. It will take 8.
Oh, 7th number. Okay.
7th number, not the number of that. It will like the 7th number. So it is 4. So left side 4 will be 1 and, oh, I did something wrong here, sorry. Because here it is 4, right? So 4 you will be getting 5 6 1 2. Where is 3? Oh, 3 will be at this side. 2 and 3. Okay. Sorry, 2 will be at the center, 1 will be at the left side, and 3 will be at the right side. Oh, 1 2 3 4 5 6 7. Yeah. So this will be 2, this will be 1, and this will be 3. 2 will be at the center. To the center of 2, 1 will be there. I can do one thing. I think it's not up to you, but if you want to remember, you can remember it. It's an in-depth topic. Okay. So here I will be having 2. Left side of the 2 will be 1, and right side of the 2 will be 3. That's it. So here for the right side of the 4 will be 5, and right side of the 5 will be 6, 7. And what are other things we got? So you said right 7 is not there, right? So you will be having 8 here. After 8, 9, 10, 11, 14, 15, 18. So in this, how many numbers we are having? 1, 2, 3, 4, 5, 6. So 6 is an even number. So 6 by 2 equal to 3. Third number is 11. 11 will be at the center. After this, 8, 9 will be at the left side, right? So in that 8, 9, 2 digits, 2 is a even number, 2 numbers, right? 2 is a even number, so 2 by 2 is 1. First number will be at the center, so 8 will be at the center, 9 will be right side to 8. And next after 11 we got 14, 15, 18, so 3 numbers. So 3 plus 1, 3 is odd number, so 3 plus 1 by 2 is second number, 2, right? So second number is nothing but 15. 15 will be at the center, 14 will be at the right left side, and 18 will be at the right side. Now if you want to search something number 8, you got at the beginning only. In the first search only you got 8. But here if you want to search when the data is not sorted, you need to search 13 times. Let's say if you want something number which is at the root side, if you want to find some number, okay, sorry, I took here 8 again. I will be getting directly, yeah, I forgot, sorry, Control Z. Yeah, 11, because I thought previously it was 8, right? 8 is a center, so there was no 7, okay, sorry. So we got 9, 10, 11, 14, 15, 18. So in this 11 will be at the center. After 11, 9 and 10 will be at the center, okay. 9 will be at the center and 10 will be at the right side. In this 15 will be at the center and 14 will be at the left side and 18 will be at the right side, yeah. So now if I want to find some number which is at the leaf node, so the top letter will be at the, you will be calling it as a root, and the bottom which is at the end you will be calling it as a leaf node, okay, leaf node. Suppose if I want to find number 8 or number 10, here when the data is not sorted I need to find 13 times, but when the data is sorted then I will go to the 8, that is the first search, it is a first, right, first, then next or else I will write this way. So it is a first search, then 10 is greater than 8, then I will go to the right side, okay, here it is my second search, then 10 is less than 9, sorry, 10 is less than 11, so I will go to the left side, this is my third search, right. Then after that 10 is greater than 9, I will go to the right side, so this is my fourth search. So last time when we have seen there are 8 records, then also we have did like in 4 searches we have find the records, right, we found them, but now the total number of records are 13. Then also we got our record in fourth time, in the fourth search we got our record. So when the number of records increases, then the search you will be getting less number of searches, you can find your data. So this is regarding the, so when the data is unique you will be having. So now so I got 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 14, 15, 18, right. The same data, let's say if I am having in other one, this is my image, I will minimize and keep aside, okay. The same data, let's say I got some duplicate, that is for the unique data, see nothing has been repeated. If I don't if I have the unique data, this is way. If I don't have unique data, let's say I got some duplicate records, I will take only few records, 1, 2, 3, 4, 2, 3, 1, 4, this is the way I got, okay. Now the data is not sorted, and when I search, definitely it will do 8 times, because it is going to search each and every record. Even though you found 4, let's say I want a record 4, even though you found 4, it will not wait, it will go and search each and every record, okay, that is there. Now what it's going to do is that, now the scenario, system will, whatever the duplicate data we have, the system will what it, so let's say you are going to sort this one, you are going to order by, sorting is nothing but order by. If you order this data, how it is going to look like 1, 1, 2, 2, 3, 3, 4, 4. Now if you want to store this data, how it is going to do the same way, 2 will be at the center, 4 records, right, 2 will be at the center, okay, 1, 3, 4 will be at the right side, in that 3, 4, right, so 3 will be at the center and 4 will be at the right side, this is the way it is going to happen. But here now, actually you will be thinking 1 will be stored, right, but actually 1 will not be stored. What system does, since they are duplicated, system will keep them some location and create some address to them. If there is duplicate data, it will create some address to them. So let's say the 001 is 001, 2 is 002, 3 is 003, 4 is 004, this is address created. So at the leaf node, even here, instead of storing the number, it will just store the address 004. That's it. So now what happens if you are searching one number, because here it needs to store, because you are having 2 3s, right? So normally it should store 3 comma 3, but it will not store 2. It will just store the address, and the user, if you want the value, you will search 3. First it will go, if it will go for the 3, it will take the address, it will search, it will try to find the address. That's it. Okay, by default, in the simple way, if you are searching 3, it will go there, but instead of 3, what happens, you will have the address. So then the data is, you will go to the address and you will get that data. It's a kind of what at the back end, what system does is that if you are having some duplicate records, if you are having some duplicate, let's say I got a Bhaskar as a one record. If I have 10 times Bhaskar, let's say I got 3 times. Instead of storing the 3 times, if I store this Bhaskar 3 times, what happens? There is a space. I am using the same space 3 times. Let's say Bhaskar take 10 bytes, 10 bytes memory. Then for storing 3 letters, I am storing 30 bytes memory. I am using the same space. I am using space for storing the same letter again and again. So what system does? It will not store Bhaskar 3 times. It will just store Bhaskar and keep it in a shared location and give the address as 100. Whoever wants to use the Bhaskar, it will just store the address there. That's it. It will not store Bhaskar as original value. It will store the address, and whoever wants to see the Bhaskar, you will take that address, go to that address. Okay, there is a Bhaskar name, so you will get the Bhaskar name. That's it. Did you get my point? Hello. So I am going to explain in the clear way, nothing to worry. So now I am going to explain the real indexes. So there are 2 types of indexes. One is a clustered and non-clustered. Okay, when you create an index, what system does? Let's say I am having a table has 100 records. When you create an index on that, the 100 records will be sorted, and a separate space is occupied for storing that sorted records. It doesn't mean that the data is sorted in the table. The data will never sort on the table. The data is not sorted on the table. The data is sorted in separate location. That location you will be calling it as an index. Okay, whenever you create an index, the data is not sorted on the table. There will be a separate space is used. In that space, it will take the records, it will sort and store it in that location, not on the table. Okay, so when you use a clustered, you use a cluster index when you have a unique data. When you use a cluster index, you use a non-cluster index when there is a duplicate data. Okay, and if you have null values, mostly if you have null values, or then basically you can use a non-cluster index. Mostly you will be using non-cluster index when it is a duplicate data. Okay, so in the cluster index, what happens when I am doing the searching? So I will be having center record at the top, less than record at the left side, and greater than record at the right side. Right, this is what I will be doing. So the center record is nothing but the root. The records which at the end is called as a leaf. So in the cluster index, when you want to find the data, if you see at the leaf will have the data, but in the non-cluster index, the leaf will not have the data. It will just have address pointing to the data. So this is a difference between the cluster and non-cluster index. Okay, are you able to get this point?
Yeah.
Manas, I am not getting any question from you. Hello. Oh, okay, sorry, okay, yeah. Okay, so basic difference between clustered and non-clustered. Clustered means you will have the data at the leaf level. Non-clustered means instead of having the data at the leaf level, it will have address pointing to the data. That's it. That is the difference between the clustered and non-clustered. Now I am going to say other concept called there is a concept in the database called table scan and table seek. Okay, so if I have a data and the data is not sorted, 0. The data is not sorted. And if you want to if I want to search any number, if I want to search 4 or any number, the table will see in the third search I got 4, but that search will not terminate. It will go and search all other records by default. So searching all the records in a table is nothing but you will be calling the concept called table scan. Table scan means you are searching each and every record. Let's say if my data is sorted, the same records if is in a sorted way, 0, 1, 2, 3, 4. So what it is going to do? By using the indexes, first it will go to the middle center one, it will go to the 2, later on less than 2 is 1, 0, right? So it will go there, and since you are searching for, it is greater than 2, so it will go to the right side. Sorted means it will have the index this way, 2 will be there at the center, 0 and 1. Same way with this one, you will have 3 will be at the center, 4 will be at the right side. So first it will go for 2, that is a 1, second it will go for 3, third. In the third step you got the data. So this is nothing but you will be calling it as a table seek. Okay, table seek. Now what we are going to see? We are going to see a normal definition for that. How you are going to create an index and what is the definition of that? What is a table scan and what is a table seek? What I want to do is that let's say we will go with the one table. Adventure works, yeah. I want to insert some duplicate data into a table, that's it. Employee, how many records do you have here? Yeah, we got 290 records. So now what I am going to do? Insert into temp table. Oh, sorry. Insert into temp. Done. 290 records will be inserted. Now I will be inserting, all the temp table will be created. Insert into temp. I am going to explain you about the insert command. I think I didn't cover you this topic, right? So I will be covering this one. Now I will delete it. Now I will, because insert into, I have given select star from, so automatically that records will be inserted into this. 290, 290, 290, 290, 290. It will keep on inserting. So now here instead of the temp, I will just select star from temp. The same number of records will be inserted into the temp table. See, 4060, 8000. So total the records will be some million. Okay, let's say they are having the records of 1,29,920 records are there. So total is double that, 2,29,000 something, 2,50,000, 2,60,000 records we have in the temp table now currently. Okay, if I want to see, I can see it in a simple way. Select, there is a column called identity. So if I do the select star from, what I will be getting? I will be getting the data. I will be getting different data. Now what I want to add one identity, like identity record for each and every record. So I can add it identity of integer as id comma star. Then I will get a unique record. Okay, sorry, it should be in the into class. So what I will do, I will create a table here. So I want to create a table with the same structure. If I want to create a table with the same structure, what I am going to do, I will just connect to the, or else I will create a table in the temp database called index. It is in the temp database, right? So I will name temp.dbo.table index. Table index, that's it. So now automatically into when I give into, what happens? Automatically this table will be created. Whatever the data we got, Okay, all the data will be inserted into this table. That's it. And that since the table is not there, it will automatically create the table with that name in the temp database. Could not find the oh sorry. See, now data will be inserted. So 2,59,840. Now if I go and see in the temp database tables, if I you can see a table called table index. Now I'll go select top 1000 rows. Now what I want to find a record where ID equal to some 10,000. I want to find a record where ID equal to 10,000. Okay. Now when I search, what happens? I'll get the ID, because as per the system we got only few records, so you will be getting the ID. Now what I'll do, at the back end, what system does, system will create a method. It will create a method such a way that the retrieving data from the table will be faster. So if you want to see that method, how the system is pulling the data, so just select this query. If you have multiple queries, it's okay, just select this query. There will be option called display estimated execution plan. Now when I click here, see, it is showing table scan. What I said, if it is table scan means it will go and check each and every record, right? So it is doing tables, it is going checking each and every record. Now what we will do, we will go to the other window. This is our table, right? I'll have the table. Now we will create index on the table. So how to create an index on the table is that create index, and I'll give the index name idx underscore. Normally we will give the index name as idx underscore the table name. The table name is table index. Okay, and it is there in the temp database, right? Temp database idx. On which table? On, I'll give the table name, and after that on which column I need to sort, right? I need to sort ID column. That's it. This is the index that I am going to create. But by default, when you create, the system will take the non-cluster index by default. Non-cluster index means when you have duplicates, right? Because here my ID is unique. I will have my ID as unique. 100% my ID will be unique. So there is no need for me to do the non-cluster index, right? I need to do the cluster index. So before index, you need to mention the index type also. Cluster. Oh. Cluster index, that's it. Okay, you need to mention the cluster index. Now I will create an index, so it will take time. At the back end, what happens? Okay, sorry. Okay, I have created an index, done. Now I will go to the same query. What I will do, I will create execution query plan. See, now what it's showing? Is it showing table seek or table scan? Previously it was showing table seek scan, right? As I said, table scan means it will go and check each and every record. Table seek means it will use a binary tree method to find the record. See, now it is showing the table seek, means the performance will be very fast. Okay, are you able to get my point?
Yeah.
So this now one more thing, I'll go to the table now, table index, or before going to that, I'll open any one of the table. Okay, I'll open any one of the table. I'll open this finance EMP, right click, go to the properties, go to the storage. Now you see there is a space for index space also. This is a table space. It will be used for storing the data. Index means nothing but you are going to sort the data. That sorted data will also utilize some space. So that space will be for the index. By default, it will be 0.00 MB for every table. Minimum it will be that. If I open any table and if I go and see the index, because there is nothing, right, there is not many records, so that's why by default it will be this size. Now let's go and see our table. This is our table index, right? If I go and see the properties, storage, now you can see the space 0.172 MB it is taking for storing the index. Okay, it is this 0.172 space is allocated for storing the sorted data. Okay, now see here in this one, execution plan means you need to select the query, or you can if you have multiple queries, just let it be, go to the execution plan, click on that, automatically you will get this plan. See, it is also showing which index are you using. See, idx underscore table in idx, that is nothing but the index which I have created here. See, okay, did you all get this? Okay, so when you have index, it will be much faster than the previous one. When you have index, it will be much faster because it will do the table seek instead of the table scan. Table scan means it will go and search each and every record. Table seek means it will go and see record by record. That's it. Okay. Now see, we can do one more thing also. I'll insert one more. I'll create one more record. I want to create a same another record with the same data, another table with the same data. So how can I do? Just give the into and the table name. Automatically the table will be created and automatically the data will be inserted. Table no index. Okay. So automatically all the records will be inserted and the table with no index will be created in this database. Now if I refresh, I can see table no index. If I click, because it has also same number of records, right? Right click storage, see, there is no space for the index. 2059,840 records, but whereas the table index, it will have the records. Okay, properties. If I go to the properties and see the storage, now you can see same number of record, but it is having space for the index because you have created index. Now what we are going to do, I am going to Control A, Control C. I am going to keep this window to the right side. So I just want to show you the different types of indexes that we are going to use. Delete from. So this is the table I am having now, where ID equal to some 1 lakh or 1 lakh. Okay. Here also I will use where ID equal, but here I am, see, both are different tables. This is a table with index and right side one is a table without index. Now if I execute this, I will get the data. If I try to execute this, here also I will get the data. Okay. Now I will select this left side window and do the query execution plan. I will select the right side window and do the query execution plan. Okay. Now see, when I click my mouse on this, what is the cost, input output cost? 0.003125. You can see estimated input output cost 0.003125. See, what is the estimated input cost? 4.44987. It is more than like 20 times more than this, right? So that is means 20, where is 20? It is some 1000 times more than this, right? So it means that the index, when you use the index, the cost is very much, but when we don't use the index, the cost, you can see how much is the cost. Okay, that's why in the companies you always use the index. Like, and one more thing, using unwanted index also is a kind of again it's a waste. Okay, because index occupies some space. If you create unwanted indexes, then you will be wasting a lot of space for storing the unwanted data, unwanted sorted data. And one more thing is that sometimes, see, now here the system is seeking the index because there is only one index. If you create couple of indexes, the system might not choose the correct index for you. It will be choosing the wrong index. Okay. Then again it is again waste. It again is, as a performance point,